Problem one. Today we will do how many questions here? We will do 8 problems, and these 8 problems coming from different universities with different majors, and hopefully this way you can see that what we learn here is actually applicable in a lot of other majors, okay, in a lot of other fields. Okay, problem one, a batch of 100 resistors has an average of 102 ohms. So the sample mean of 100 resistors is 102 ohms. And the population standard deviations to be 8 ohms. Test whether the population mean is 100 ohms. Population mean is 100 ohms at alpha equals to 0.05. That's what we know. Okay, so step one, claim the population mean is 100 ohms. So step two, hypothesis. Hypothesis, null hypothesis, the mu equals to 100 ohms. And the alternate hypothesis, the mu is not 100 ohms. Now the claim is here. And because it is equal, not equal sign, that will be a two-tail. I think this is the first time we deal with two-tail case. Let me more space here. Okay, so test statistic. Yeah, because we know the population standard deviation, we use standard normal distribution. The sample mean is 102. The claim mean is 100 over the standard deviation is 8 over square root of 100. This will be 1/4 times 10. So that's 2.5, huh? That's 2.5. Let me insert more. Step 4, the p-value with standard normal distribution. The C-score is 2.5. That's the test statistic. So the p-value will be two-tail. Okay, the p-value will be two-tail. So the p-value will be 2 times normal CDF 2.5 to infinity, oops, to infinity E99 now. E99, 0, 1. So 2.5 to infinity, I get 0.01242. And because the p-value is less than the alpha, which is 5%, then the informal conclusion reject null hypothesis. Reject null hypothesis, and let me insert. Step 6, conclusion. At 0.05 significant level, there is insufficient evidence actually there is sufficient evidence to reject the claim. That the population mean is 100 ohms. So the evidence shows that it is not 100 ohms. Okay, now that's for part 1. From here, I have 2 things to say. The method I showed you earlier, actually on yesterday and today, is called p-value method. That's p-value method. Now, how about traditional method? Now, you will see that because we use calculator, then p-value method will be faster. Okay, p-value method will be faster. Traditional method, on the other hand, only differ in step 4 and therefore step 5. In step 4, in traditional method, let me line this here. Step 4 in traditional method is called critical value. In traditional method, step 4 instead of p-value is critical values. Now, what is critical value? Critical value is the following. Critical values is the C-score such that the area of the tail is equal to significance level. Okay, now because this is 2 tail, and we have 2 tail here, and the area to the left plus the area to the right should be equal to alpha. From step 2, we see that it's 2 tail. Right? So the area of these 2 total area should be equal to alpha, in this case 0.05. 0.05, that's the total area. Now then, the question is, what is this C score here? C critical, not C, but C critical. Okay, now, the thing is this number here will be the opposite of that. Okay, so the C critical equals to inverse norm 0.975. How do you get that, Thomas? Well, because the alpha is 5%, right? So this is 0.025 and this guy is 0.025. Now, if that's 0.025, then the area from negative infinity up to here is 0.975. Okay, so inverse norm 0.975, 0, 1. I believe that's 1.95996. That's the critical value. Okay, now the thing is, because it's two-tailed, we have two critical values here. Okay, we have two critical values. So the C's critical will be, we update this, it becomes plus minus 1.95996. Actually, it's supposed to be like this, plus minus here and then plus minus here. So I don't need to update it. Plus minus 1.95996. How about the others critical value, Thomas? We will have 7 other problems to work on. So don't worry, okay? Don't worry. We have other 7 problems to work on, and for each one of them, I believe I will have time to do the critical value also, okay? Now, so what if we have the critical value? Now, here's the thing. We will reject null hypothesis. So for step 5 in traditional methods, in step 5, we will reject null hypothesis. Reject null hypothesis if the test statistic is in the tail region. The test statistic in the tail region. The one I shaded in yellow down here, okay? That tail region is also called the rejection region. Rejection region, or also called critical region. Okay, now otherwise, fail to reject null hypothesis. Okay, now, so from what we have earlier, you see that this is plus minus 1.95996, while our test statistic is 2.5. Test statistic is, oops, sorry. Our test statistic is 2.5. Now you can see that test statistic is in the critical region, in the tail region. Okay, so then we come up with the same informal conclusion, reject null hypothesis, and therefore the same conclusion that we reject the claim. Okay, now you will see that step 4, either p-value method or traditional method, will always come up to the same conclusion. Will always come up to the same conclusion. Okay, but like what I said before, p-value method is more is used a lot more frequently recently. Okay. Now, actually, I want to say more. So today, I basically try to do as much as possible from this chapter 10, just finishing up chapter 10. Just finishing up chapter 10. Next one, your favorite. Calculator. How to use calculator. And we can use hypothesis, we can confirm our hypothesis testing. Hypothesis testing on C. Oh, because we are testing, I think I should say testing, hypothesis testing on mu with sigma node. we will use C score, right? We will use C score or C test statistic. Okay, now then on your calculator, it will be, you use C test. You will use C test. Now, how to get that C test? You go to stats, and then go to test on your calculator, and then C test. Okay, now let me show you the calculator. Okay, so give me a second. But never use calculator as your answer in my test. You use that only to confirm if you get it right or not. Okay, just use that to confirm. Only use that to confirm if you get the answer right or not. Again, one of the main reason is because one of them is because the number of decimal places. So you go to stats, and then go to test, and then use C test. Now, what kind of information you have? Do you have data or do you have statistic? In this case, we have the stats. Okay. Now, mu0 is this is the constant for null hypothesis. So the constant for null hypothesis is 100, and then population standard deviation is 8. Okay, the X bar is, as I remember, 102. And then the sample size was 100. And we are testing the two-tail. Okay, now this part here, the second from the last line, will always refer to the alternate hypothesis. Okay, not the null hypothesis. You see the notation is not equal to, less than, greater than, all of them without equal sign. So you know that's the did I say null hypothesis? Alternate hypothesis. Okay, it refers to the alternate hypothesis. Okay, enter, and then calculate. So this is what we get. This is what we get. Okay, so it will give us the C score 2.5, the p value, and actually that's what we need, right? Okay, let me quote that here. Huh? Give me a second. What did I do? So when you use your calculator, what did I do? Okay, here. So we get the C score and the p value. Okay, so when you have a multiple choice question in which you don't need to show your work, okay, then you can just use calculator actually, right? And that's why that becomes, instead of a question that's worth like around 9 points, they suddenly make it just 1 point question. And that's when you use your calculator. Okay, so just for this one question, question 1, I have 4 things to say. First, that even though this is a stats class, but you see this question coming from University of Utah, electrical and computer engineering department. So even if you go to engineering department, you still see this. Second, we went over the p-value method. And after we're done with that p-value method, the new stuff here is that I teach you traditional method. So traditional method is actually looking at the alpha, adjusting if it is 1 or 2 tail to find the critical value. And for step 5, we will reject null hypothesis if the test statistic is on the critical region. Okay, that's the third part. And then the fourth part for this example 1 is I teach you how to use calculator to confirm your number. Okay, now notice that this C-test, this calculator here does not tell you what the conclusion should be. Okay, that's because in your question, when you plug in numbers earlier, you didn't tell them what's the alpha. So they won't be able to tell you what's the decision supposed to be. Okay, but they tell you the p-value. Now, one of the benefit of p-value is that we will then know at what alpha we will start rejecting the null hypothesis. Okay, at what alpha we start rejecting the null hypothesis. Okay, let's go on to number 2. Let me give a lot more space here. In 2002, so this is Boston University School of Public Health problem. In 2002, the mean weight of men was reported to be, so in 2002, the mean was reported 191. Now, suppose that an investigator hypothesizes that weights are even higher in 2006. Okay, so in 2006, they expect it already increases. A random sample of 100 American males in 2006 turns out to have average of 197.1 pounds. So X bar 100 equals to 197.1 pounds with standard deviation of 25.6 pounds. Now the thing is it from sample or from population? The standard deviation here is sample of or population. Now then you trace back. The wording is that this 25.6 coming from a random sample of 100. Okay, so from there we see that this is sample standard deviation. Now use 3% significance level. Okay, going over step 1, the claim. What's the claim? Hypothesizes that the weights are even higher in 2006. The mean weight for men is even higher in 2006. Now that's my claim, okay? But I think you can word it differently. Also just quote that you say weights are even higher in 2006, okay? Even though I prefer you to clarify what weights you're talking about. The weights of men, okay, are even higher in 2006. Now step 2, hypothesis. Hypothesis, the alternate hypothesis, the mean is higher than 191. That's where the claim is, and that will be the right tail. Okay, so this is the mean is less than equals to 191. Step 3, test statistic. Because we don't know the population standard deviation, we will use T. So T equals to, what is the sample here? 197.1 minus 191, that's the one being claimed, over 25.6 over square root of 100. Okay, so I get T equals to, you know what, let me just do this. This is T equals to 6.1, that's 61 divided by 25.6. I get 2.38281. Okay, so the p-value will be, see, that's a right tail. Let's say this is T distribution, this is 2.38 something. We want to find the area here, right? And it's one tail, right tail. So I don't need to multiply by 2. P-value equals to TCDF 2.38281 E99, the degree of freedom 99. From 38281. What do I get here? 0.00954. And because this p-value is less than alpha, this p-value is less than alpha. Hold on. What number did I take? P-value is less than alpha, so the informal conclusion will be reject null hypothesis. And therefore, we can conclude step 6 conclusion. And 3% significance. Is it 3%? Yes, that's right. At 3% significance level, there is sufficient evidence to support the claim you see the claim in the alternate hypothesis, right? Because the claim is in the alternate hypothesis, then we try to support it. Okay, to support the claim that the mean weight for main is, I need to put it as is even higher in 2006. That's for the conclusion. Now, how about if we go back to step 4 and show the traditional method? In traditional method, we will use critical value. Because there's only one tail, then there will be only one critical value. There's only one critical value. Okay, we want to find what is the critical t here such that the area to the right is 3%. You want this to be 3%. Okay, which means the area to the left is, 97%. Right? Okay, now let's use our screens. Oh, okay. I will go to inverse t. Okay, now the area to the left is 97%, 0.97. Degree of freedom is 99. So t critical equals to inverse t. The area to the left, always area to the left. Degree freedom 99. And I get t is what again? 1.9 something. 1.90259. Now the thing is this is the t critical, while the test statistic is here. This is a test statistic. Okay. Now because the test statistic is in the critical region, then we reject null hypothesis. Okay. Now how about calculator? How about if we use calculator? Then it will be using t-test. We'll use t-test. Okay, we'll use t-test. So it will be stat test t-test. Okay. Now then, what's the data? We want the mean to be 191. That's the number from null hypothesis. Okay. The X bar is 197.10. This one will be. And then the sample standard deviation 25.6. The sample size is 100. We want that to be the alternate hypothesis. We want that to be greater than the 191. Calculate. Boom. I hope you can confirm what we have there. Our t test statistic is 2.38281. Our p-value is 0.00954. Now there's a chance that your p-value is a bit off. Okay, if you compare to my old solutions in my old tests, that's because we use table, and in our table the degree of freedom actually varies. Not like the one, if we use calculator, we can use any degree of freedom. In our textbook, in our table, the p-value we use will maybe approximation. Okay, depends on what degree of freedom we have on our table. Now again, this t-test from your calculator only tell you in the end the p-value, and therefore you need to be able to decide on your own what's the conclusion. Okay. Let me snap this and put it in our especially these two. Okay, now let's go on. Let's go on. What happened with if we do problem 3? Let me give myself some space here. If I do problem 3, this is New York University Denver School of Business. A healthcare actuary has been investigating the cost of maintaining cancer patients within its plan. These people have typically been running up costs at the rate of 1,240 per month. Then a sample of 15 cases, so that's our N, for November, give an average of 1,080. So the mean, sorry, that should be X. That's X bar of 15 is 1,080. With standard deviation, now that's from the sample, right? Sample of 15, standard deviation of 180. Is there significant change? So is the mu still 1,024? They don't tell us the alpha, so we will use 5% because not given. So the rule of thumb is if we don't have the significant level, we use 5% significance level. Okay. Now the thing is, there's no explicit claim here, so we need to rephrase this though. We need to rephrase that. Okay. Rephrase that for our claim. Claim. There is a significant change. By the way, the word significant in statistic refers to 5%. There is significant change in maintaining in the cost of maintaining cancer patients within its plan. So step 2, hypothesis. If it changed, means it's not equal anymore. Right, so the mu is not equal to 1,240. Right? Here that we see this is the claim, and because that's not equal to that, that's a true kill. Let's go on with test statistic. Because we don't know population standard deviation while testing the mu, then we use T, whose sample mean is 1,080 minus the claim mean 1,240 over 180 divided by square root of 15. So let's use our calculator to compute that. I get negative 3.44265. For p-value, it's two-tailed, so we will have two critical numbers. We need 95%. Oh, I'm sorry, this is p-value. What am I doing? No, no critical, no critical. It's p-value. My bad. I'm thinking ahead. So the p-value, that's negative 3.44 something. But because it's two-tailed, whatever the area here, I need to double it. Okay, so p-value is 2 times TCDF negative infinity, so negative 3.4465, degree of freedom 14. I get 0. Hold on. 0.00396. Let me check again. I think I typed something wrong earlier. Yeah, 0.00396. That's already been doubled. And therefore, in our step 5 informal conclusion, we'll reject null hypothesis. Again, reject null hypothesis again. Seems like we keep on rejecting null hypothesis. And then step 6 conclusion. At 5% significance level, or you can also say at alpha equals 5%, there's sufficient evidence to support the claim that lazy teacher, there is significant change in the cost of maintaining cancer patients within its plan. Then how about the p-value? P-value. How about the critical value? Because it's two tails, it's critical values. We need significance level 5% for two tails, so it's 2.5% here. That's 2.5% here. the T critical will be there. Okay, so the T critical equals to plus minus inverse T 0.975 degree of freedom 14. So let's see, that's second distribution inverse T area to the left, make 0.975 degree of freedom 14. I get plus minus 2.1 something. So it's plus minus 2.14479. Okay, but notice that our test statistic is negative 3.44. Okay, the left hand critical value is negative 2.1 something, and the test statistic is even to the left of that. It's on the tail region. So we come up with the same informal conclusion. That is, we are to reject null hypothesis. Okay. Now, how about calculator? Now, again, you only use calculator when you need to confirm your answer. So stat test, we are testing mu without sigma known. Mu 0 is 1240. Sample mean is 1000. 1080. Sample standard deviation 180. Sample size 15. That's a two-tail. I hope you see that we get the same number. Okay, that's all good. I go on. Number 4. Now, this is something new. This is something new. But even though it's something new, I believe you can follow me. This number 4 is testing the P. The mayor claims that blacks account for 25% of all CD employees. Now, a civil rights group disputes this claim and argues that the CD discriminates against blacks. Now, a random sample of 120 CD employees has 18 blacks. So the X equals to 18. The N is 120. So from there, we will get the P hat equals to what? I think it's 15%, yeah. That's 0.15. Test the mayor's claim at, so the alpha is 0.05. What is the mayor claims? Notice that the mayor claims 25%. The civil right groups disputes that claim. So in some sense, the civil right groups disputes that because the word they use is discriminate against black, then the civil right groups claim is it's less than 25%. Okay, but here the one we are testing is we are testing the mayor's claim, not the civil right group's claim. Okay, so step one, the claim. What is mayor's claim? Blacks account for 25% of all city employees. Step two, hypothesis. So you know we are actually shifting to 10.2 here. Hypothesis. The null hypothesis, the alternate hypothesis. The null hypothesis is the claim that P, the proportion, is 25%. Okay. Now, why I emphasize this? Test the mayor's claim. The mayor's claim is 25% now. So if that mayor's claim is incorrect, then the P is not equal to 0.25. Now notice that, let me put it in other color here, maybe in green. If we were testing a civil rights group's claim, then step one will be blacks account for less than, because you want to accuse this mayor or the city, actually accuse this city to discriminate against black. Okay, so that implies it's less than 25% of all city employees. Second, the hypothesis will be the alternate hypothesis P is less than 0.25. So what happened is in our test, in our work here, because we are testing the mayor's claim, it becomes, this is the claim, and that will be a two-tailed test. Okay, while if you are testing the civil rights claim, that will be, the claim will be with the alternate hypothesis, and that will be a left tail test. The result may be different. That's why it's important for us to see what claim we are actually testing against. Okay, what claim we are testing against. Now, let's go on. What is new for us here is that we are testing P now. Okay, we are testing P now. But the former pretty much very similar. Test statistic. Will be Z equals to P hat minus P over square root of PQ over N. Now we have this formula yesterday. We have this formula yesterday, and this will be 0.15 minus 0.25 over square root of, not P hat. The thing inside here is PQ, not P hat. Okay, it's PQ. So 0.25 times 0.75, that's the Q, over 120. Okay, so that's 0.15 minus 0.25 divided by the square root of 0.25 times 0.75 over 120. I get negative 2.52982. Okay, and then step 4, p value. That's a true tail, right? And this is negative 2.5 something, but it's two tail, right? So p value is 2 times normal CDF negative E99 negative 2.5298201. I get 0.01141. Oh, we still reject null hypothesis. Oh. I think the alpha is 5%, isn't it? Yeah, the alpha is 5%. We still reject null hypothesis. So step 5, informal conclusion. We still reject null hypothesis. And then step 6, conclusion. At 5% significance level, there is sufficient, you see the claim is null hypothesis, right? So there's sufficient evidence to reject the claim that blacks account for 0.5% of all CD employees. Okay, now how about if we use critical value? Because it's two tails, critical values has two numbers here. Now we want the critical values. This is C critical such that the total tail region, the total area of the tail region is 5%. So C critical will be plus minus inverse norm of 0.97501. Now that's because of 2.5% here, 2.5% here. This is 95%, right? So we see critical will be the area to the left of that number, that critical number. And I believe we will get plus minus 1.95996, while the test statistic is negative 2.5. This is the test. Okay, still in the rejection region. Now, how about calculator Thomas? How about calculator, then it will be stat test 1 proportion t-test. 1 proportion t-test. What is our p0? 0.25. X naught 18. N naught, the population sample size is 120. We are testing two-tail calculate. Okay, that's what we have there. Yeah, we will use for calculator. We'll use stat test 1 proportion C test. Actually, the proportion, either 1 or 2 proportion, is always, as long as it is proportion, it's always Z. It's always C test. Okay. Now, right now is 9/11. Ooh, that's not a nice number. 9/11. Let's take a little break. We come back at plus 10 minutes. Let's say 9:20. Let's come back at 9:20. Okay, let's continue. Number 5. I actually should just give this to you to do earlier. Number 5 is a question from University of Washington, Department of Statistics. Chris works for MESA air pollution study at UW and studies the correlation between air pollution and the disease atherosclerosis. Nationally, 40% of adults suffer from atherosclerosis, so that's the P. Now, Chris suspects the proportion of people with atherosclerosis in high pollution areas is higher. So what he is suspecting is P is greater than 40%. Now then, he gave a random sample of 600. Find 270 has the same, that issue, atherosclerosis, significance level 0.01. Now, is this good evidence that people in high pollution areas are more likely to have atherosclerosis? That will be our claim, I believe. Okay, that will be our Chris claim, to be more precise. Claim. People in high pollution area are more likely to have atherosclerosis. Hypothesis. Null hypothesis. The P is less than equals to 0.4. The claim is with the alternate hypothesis. This is the claim, and it is a right tail. Okay, and then step 3, test statistic. C equals to, I need to find the p hat. What's my p hat? P hat is 270 over 600. That's 0.45. 0.45, so this will be 0.45 minus 0.4 over square root of 0.4, 0.6 over 600. That will be 0.05 divided by the square root of 0.4 times 0.6 over 600. Boom. 2.5, exactly 2.5. So our p value will be, this is a right tail, this is 2.5. Minus the area to the right. Its p value goes to normal CDF 2.5 E9901. Zero 0.00621. And then step 5, informal conclusion. What is the alpha value? Oh, the alpha is 0.01, but this is even still less, huh? So informal conclusion will be still reject null hypothesis. And step 6, conclusion. At 1% significance level, at 1% significant level, there is sufficient evidence. There is sufficient evidence to support the claim that sufficient evidence to support the claim that, let's say, teacher tends to do copy and paste. Okay. Now go back. What happened to test statistic? Let me do a bit higher there so that we have enough space for if I do test statistic. Okay, it's a right tail test. Okay, so I need to find C critical here. I'm sorry, not test statistic, critical value. Duh. And C critical equals to inverse norm. The area to the left is 0.99. 0.1. Okay, and I think that's 2.33 something. Yeah, 2.32635. Okay, and the thing is the test statistic is even to the right of that. About calculator. Yeah, you can try to do your own calculator. I do mine. Okay. You do yours, I do mine. Okay, let's see. Do you have what I have? So the test statistics is 2.5, and then the p-value is this. Okay, we are good. Okay, just to confirm what we have. Okay. Number 6. Number 6. Let's insert. This is still proportion. This is still proportion. Number 6. University of California, Irvine, School of Information and Computer Science. A new drug is being proposed for the treatment of migraine headaches. Unfortunately, some users in early tests of the drug have reported mild nausea as a side effect. Now, the FDA will reject the drug if it thinks that more than 15% of the population would suffer from this side effect. In an experiment to test the side effect, 400 people who suffer from migraine, so they actually looking for people who suffer from migraine, okay, receive this new drug, and 80 of them report nausea as side effect. Now, will the FDA reject the drug? So step 1 claim, the FDA will reject the drug. Or alternatively, which is in my opinion better, if you say instead that more than 15% of this new drug users report or suffer from nausea as side effect. So actually, either one, you can use either one of them. Okay, you can use either one of them. Step 2. I prefer the blue one because in that blue sentence there, we actually see the proportion explicitly. Okay, even though I cannot blame you if you say the FDA will reject the drug based on the passage. Now, the thing is the FDA may reject the drug for other reasons, right? Okay, so that's why we prefer the blue one. Okay, hypothesis. Oh, by the way, do not politicize that. Okay, it's not about black over blue. Okay, no, I just happen to use this color. The P is greater than 15%, less than equals to 15. Okay, I think I need my P hat. So this P hat will be 80 over 400. That's 1/5, so 0.2. The claim is here. This is the claim, and that's a right tail. Oh, by the way, do they tell us the alpha? I didn't write it down. Oh, they don't tell us the alpha, huh? So, okay, alpha is 5%. Then. Okay, then step 3 test statistic. C equals to 0.2, that's the p hat, minus 0.15, that's the p, over square root of p q over the sample size is what again? 400. 0.05 divided by the square root of 0.15 times 0.85 over 400. That's 2.8. Oh, that's really big. 2.80056. So step 4, p value. That's the right tail. This is 2.8 something. So see, a p value is normal CDF 0.80056 infinity 0.1. Well, actually, you will see that when you do normal CDF, the E99, as long as it's standard normal, the mean is 0, the standard deviation is 1, you can replace the E99 by 10 or even by 100 or even 10. It's good enough. Okay, we will get the same value. What will this be? So normal CDF. I get 0.00255. Ooh, that's small again. So that's informal conclusion. Informal conclusion will still be rejecting null hypothesis. So far, we always reject null hypothesis, huh? Okay, but that's not always the case, though. If that's always the case, what's the point of doing hypothesis testing if we know the end story already? No, it's not always true. Okay, the conclusion at 5% significant level, there is sufficient evidence that to support the claim. Again, let me copy paste. The FDA will reject the drug, or to be more precise, that more than 15% of these new drug users suffer from nausea as a side effect. How about the critical value? That's a right tail. The area to the right is 5%. So the area to the left is 95%. So C critical equals to inverse norm 0.95. It's 5%, right? Yeah, it's 5%. 0, 1, I think that's 1.64 something. 64485. How about the calculator? You do it on your own calculator. So I don't show you my calculator right now. X is 80. The N is 400. And we are testing the right foot. Okay, that's for this part here. Now, we have two more questions, but question number 7 and number 8 is something other. That's actually from 10.3. That's from 10.3. Let's see what we have here. Problem number 7. The observed variance for 100 measurements gear diameter is this. So the sample size is 100. The sample variance is 0.00003969. Okay, or they give us here the standard deviation is 0.0063. Now test if the true variance is equal to 0.01. Now you will see that the difference will be in test statistic. The test statistic later on will be chi-squared. Maybe I use blue color here. The test statistic is chi-squared equals to n minus 1 s squared over sigma squared. Okay, that's the test statistic. So the claim, the true variance is 0.01. Hypothesis, we are testing the variance. So the true variance or population variance is sigma squared equals to 0.01. The claim is here, and it is two-tailed. Step 3, test statistic. Pi squared equals to n minus 1, that's 99, times the sample variance, that's 0.00003969. Oh, a very small sample variance, over the population variance 0.01. 99 times 0.00003969 over 0.01. I get 0.39293. It's very, very small. So step 4, how about p-value? And we sketch that chi-squared distribution. Chi-squared distribution looks like this. Okay. Now the peak, that's why you need to know the peak. The peak, the highest point is approximately the degree of freedom. That's approximately the degree of freedom. Now, then our test statistic is here. Our test statistic is here. Now then, what is the area to the left? And because this is a two-tail test, whatever that area, I will double it. Okay, so this will be, the p-value will be, 2 times, inverse chi. I wonder if you remember how to use this. 2 times inverse chi. I think this is the area to the right if we use chi distribution. Yeah, it will be the area to the right. Oh, hold on. I just need the area. I'm not trying to find the test. I'm not trying to find the critical value. My bad. So no, it's not. No. I can just use chi-squared distribution, chi-squared CDF. Sorry, not this one. I need the area, so this will be 2 times chi-squared CDF. That's from 0 to 0.39293, and then degree of freedom is 99. That's basically 0. It's so small. It's so small that they call that 0. Okay, so then from here we see that, oh, again, they don't tell us the alpha. Oh. So we use alpha is 5%. So informal conclusion. Reject null hypothesis. Yeah, I think I need to talk a bit more about this though. And then conclusion. At 5% significance level, there's sufficient evidence. Actually, there's sufficient evidence to reject her, because the claim is with the null hypothesis. How did I phrase the true variance is? How about the critical value? Now, they don't tell us the alpha, and because it's two-tailed, then I need to have the figure where this is the chi-square critical right, this is chi-square critical left, where the area of each tail is 2.5%. Okay, now then this is where we use the inverse chi. So chi-square critical right will be inverse chi. The area to the right is 0.025, degree of freedom 99. And chi-square critical left will be inverse chi 0.975, degree of freedom 99. Okay, let's use that. It will take some time though. I get 128.42199. While chi-squared critical left what is the degree of freedom? Yeah, the n is 100, so 100. The unfortunate thing about this chi-square thingy, hypothesis testing on chi-square, we don't have calculator to confirm our work. So you are basically on your own. You know, you are basically on your own. I get 73.36018. Okay, that's the chi-square distribution. Now, I said earlier that I want to go over this question a little bit. I want you to realize how important it is for us to state the claim correctly. To state the claim correctly. Here's the thing. When you are producing gears, right? When we produce gears, would you like, or produce any product, would you like the variance or the variation to be big or small? When we are producing a product that we need to use in other tool or other product together, we want the variation to be small, right? Okay, we want the we want the variations to be small. So when you are testing the true variance equal to 0.01, you are trying to say that it is 0.01, not more nor not less. Okay. So apparently here, the conclusion we get will be against, for or against the claim if the true variance is 0.01 or not. Okay. While what we would actually like is we want to see if the standard deviation, or in this case, the true variance, is less than 0.01. It's like okay, I need the variance to be small. The maximum tolerance that the variance that we can accept is 0.01 for the variance. Okay, now then I take the variance of 100 measurements, and it turns out to be this very small number. Now we wonder if that's a good thing or not. Okay, now if I change my claim to be the true variance is less than 0.01, now you will see that we will support the claim. Okay, this time we'll reject the claim. because the claim is null hypothesis and we reject that null hypothesis in step 5. Okay. Now, number 8, the last one, problem 8. Problem 8, a manufacturer of hard safety hats has designed a helmet so that the mean force transmitted by helmet to the workers is 800 pounds, with standard deviation to be less than 40 pounds. The tests were run on random sample of 40 helmets, that's our N, with sample mean of 825 and sample standard deviation 48.5. Now we want to make sure that, do the data provide sufficient evidence at alpha equals to 0.05? So that's our alpha. Let me write it down. To conclude that the population standard deviation exceeds 40. So population standard deviation exceeds 40. Now, I need you to be careful with this. Notice that the question we need to answer is, can we conclude this? Can we conclude this? So you see that the conclusion doesn't have equal sign, right? Okay, while in the first statement, you want the standard deviation to be less than 40 pounds. You see what I mean? But the question we need to answer is about this one, not this one. Not this one. Okay? Thomas, one of them is exceed 40 pounds, the other one less than 40 pounds. What's wrong with that? They are complementary, right? No, they are not exactly complementary. No, they are not exactly complementary. The difference is exceed 40 means greater than 40. Less than 40 means less than 40. Where's the equal sign? Okay, so we cannot use how to say that? They are not complementary to each other. You know, the complement of exceed 40 pounds is less than or equal to 40 pounds. Okay, so this is not the one I canceled the highlight earlier, was not the claim. Okay, the claim is the population standard deviation exceeds 40 pounds. Step 2, hypothesis. Null hypothesis, alternate hypothesis, sigma greater than 40, sigma less than equals to 40, and the claim is with the alternate hypothesis, and therefore, in this case, greater than. That's a right here. Then we go on. Statistic. I squared equals to 39 times 48.5 squared. Notice I squared it because this is sample standard deviation, and what you need here is population, standard sample variance. This is the position for sample variance, while the one given to us is sample standard deviation. Okay, let me leave it there so that you're aware over 40 squared. Okay, and use this color. The common mistake here is sometimes about do we use square terms or not? Do we square it or not? Depends on the statement though. Okay, depends on the statement. But in that formulas, in these test statistic formulas, you have degree of freedom times sample variance divided by population variance. Okay, now then it will be 39 times 48.5 squared divided by 40 squared. I get 57 point something, 57.33609. So the p-value, that's a right tail for chi-square distribution. Okay, so the p-value is chi-squared CDF 57.33609 to infinity, degree of freedom 39. I get 0.02928. The alpha is what? 5%. Okay, so we still reject null hypothesis. All of the problem reject null hypothesis. Surprise. That's by coincidence. Okay, I didn't purposely do that. Reject null hypothesis. For part 6. Conclusion. 5% significance level. There is sufficient evidence that to support the claim. Population standard deviation 6. Doesn't work. I will write it. I'll just write it down. That's for the last step, and step 4 for critical value. We want to find the cutoff score, chi-squared critical, such that the area to the right is 5%. Then chi-squared critical will be inverse chi, the area to the right 0.05, degree freedom 39. Okay, what will that be? Let's see. $54 something. Okay, now I hope through these 8 examples, we see first how to apply this template of these 6 steps. Every time I ask you to do hypothesis testing, then you will need to do these 6 steps. Okay, and then also through all these examples, you see how I show you how to deal with the critical values. In case that somebody asks you the critical value in traditional method. Okay, and for 7 or 6 of these problems here, I also show you how to use calculator. The only time we cannot use calculator for hypothesis testing is when we are testing the population variance or population standard deviation. Now, I will not give you the suggested homework yet today. I don't want you to study from this yet. I want you to, well, I don't want you to do other exercise, but to read these examples for now. Okay, if possible, try to do the problems again. Okay, between today and tomorrow, try to do the problems again. Okay, make it exactly like what I do here. Okay, but I want you to focus on your test 3, which is this Thursday. Okay, which is this Thursday. I believe if you look at my YouTube video, you will see a video clip about how the Zoom Proctor test should be done. Okay, so if you have a chance, go to the YouTube, see your channel, see my channel on Summer Math 227 Statistic. I think I did it last week on Thursday. I posted last week on Thursday. So what date was that? 20th, 18, 16. So it will be July the 16th last week. That's when I posted it. Okay, but don't worry too much about this chapter 10 yet, because your test will only go up to chapter 9. Tomorrow I will start chapter 11. Okay, tomorrow I will start chapter 11. Now, I don't need you to know how to, well, I need you to know how to do this already. Okay, but just study from these 8 examples first. Okay, just study from these 8 examples. Don't need to look at your textbook for now, but focus on your test 3. That's a lot more important. Okay, then, see you tomorrow.